Welcome to solverfy.
So here we have a decision to be made. So the decision is to determine how much of each type of feed to use to meet nutritional requirements. And so we do have a series of constraints on those decisions and an overall measure of performance. And so those constraints is the calorie constraint, they need at least 8,000 calories. Vitamin constraints, they need 700 units of vitamins. Toxicity constraints, no more than a third of the diet by weight can be type A, and non-negativity constraints, so the amount of each feed cannot be negative. The overall measure of performance is to minimize the cost of the pig feed whilst meeting the calorie and vitamin requirements of the pig. So then in part B, you've got the quantitative expressions, so we can let X be the pounds of feed of type A, Y be the pounds of feed of type B. And so our constraints, the calorie constraint is 800x add 1000 y is equal to or greater than 8000. The vitamin constraint, 140x add 70y is equal to or greater than 700. The toxicity constraint, x is equal to or less than 1/3 of x add y. And finally, the non-negativity constraint, x, y is equal to or greater than 0, so they can't be negative. And the overall measure of performance is to minimize cost, where 0.40x add 0.80y. And so we can look at linear programming model on a spreadsheet. So our objective function is to minimize dysfunction here, subject to those constraints that are outlined here. So we can solve this linear programming problem using a spreadsheet solver to find the values of x and y that minimize the cost while satisfying the constraints. And then we can look at our algebraic function. And so our objective function, again, is to minimize 0.40x at 0.80y and subject to those constraints. So the algebraic function of the linear programming model involves expressing the objective function in each constraint in terms of the variables x and y, and then solving for those variables that satisfy all constraints and minimize the objective function.